Good morning, CSEC students. Welcome to the Kemet Maasai Academy. Today we're going to be doing matrices, finding the determinant and the adjoint. Now we need to know how to find the determinant and the adjoint so that find the inverse of the matrix. How to find the adjoint. This is the fundamental step in finding the inverse. This is what we're going to do first. Learning how to find the determinant and the adjoint. The work that we're going to be doing is based on 2x2 matrices. So that's 2 rows by 2 columns. And that's a typical matrix that you're going to encounter at level. Now, bear in mind, matrices can be in any form. We can have 1x3, 3x1, 8x5. It doesn't really matter. It can be of any order. So we're focusing on the 2x2 matrix. And we're going to start off by determinant. Work some examples of that. Maybe about, let's say we can work about 6 examples of each, and then we go on to the adjoint and work about 6 examples of that, right? So by then you will be well versed in finding the determinant and the adjoint, and then the next live session that we do on matrices, we can go on to find the inverse of the matrix. I want to welcome the scholars who are joining in the chat. Welcome to scholars on YouTube, on Facebook, on Twitter, wherever in the universe you are, welcome. Feel free to post your comments. Feel free to post your answers, your questions as we go along. So let's get into it. All right. So let me write the formula. Make sure it's on the thickest one. So for determinant of a 2x2 matrix. So let's say we have any given matrix. Let's say matrix A. We use to name our matrix. So let's say matrix A is 4, 3, -2, 5. So determinant, and this is how we'd write determinant like that. To find the determinant, or you know what I should do? I'm going to use just letters for now. Let me use. So let's say we have A, B, C. To find the determinant, it would be A times B minus B times C. So it's the whatever the number is times the D value minus the B value times the C value. Okay. So we're going to work an example. So let's actually put in some figures now. So let's say matrix A is, so 4, negative 3, 0, 2. So the determinant of A, that would be, remember, A times D minus B times D. So it will be 4 times 2 minus negative 0, which is D times C. That times that. So it's almost like we're cross multiplying. That times that minus that times that. So that would be 4 2s 8. Negative 3 times 0 is 0. 8 minus 0 is 8. So the determinant matrix A is 8. All right, so we're going to work a couple more. All right, so let's say matrix now, and that's 1, 6, negative 3, 4. So the determinant of B would be 1 times 4 times negative. And that would be 1 times 4 is 4. 6 times negative 3 is negative 18. And multiplying it by this negative that's in front of the bracket here. So negative times negative will be positive. So it will be 4 plus 18. And that will be 22. So the determinant 22. All right, so matrix C, negative 5, negative 3, 1, 10. So the determinant of C, that will be negative times 10 minus 3 times 1, and that gives negative 5 times 10, that's negative 50. Negative 3 times 1 is negative 3, and multiplying it by negative sign here, that will be positive 3. 50 plus 3 is negative 46. All right, so give me some feedback. Let me know if you understand so far. I'm going to go ahead and do a couple more examples of the determinant, and then we go to the adjoint. finding the adjoint. All right, so let's do some examples. All right, so now we're at D. So matrix D, -11, 0, -6, 7. The determinant of D, that would be -11 times 7 minus 0 times -6. -11 times 7 is -77. 0 times 4, that's 0. So the answer is -77. All right. E. So let's make these all positive. 3, 9, 4, and 10. So the determinant of E would be 3 times 10 is D, 3 times 10 minus B times C. So that's minus 9 times 4, 30, minus 36. So the determinant is 6. All right, and we're going to do 2 more. Write this E properly, so that should be an E. I don't know if that looking. Okay. All right. So we're going to do 2 more because it's pretty straightforward. I'm sure you would agree. It's pretty straightforward. So F, matrix F. So that's 1, 3, -5, 2. The determinant F would be 1 times 2, so A times D, minus -5 times B times C, and that's 1 times 2 is 2. The 5 3 is 15 times this negative here, that's positive 15. So that's 7. Last one, determinant G, so matrix G, and let's say that's 15, -7, -20, 3. All right, so the determinant of G, so that would be -3.
Miss, can I have a water break, please?
15, -3. -10 times -20. And that gives, so 15 times negative is -45. -20 is a positive 140. And remember, we still have negative sign in front. So what we have now is -185. That will be the determinant. pretty simple and straightforward. So remember, it's A times D. This is A, B, C, D. A times D minus B times C. And that's it. So now we're going to go on to finding the adjoint of a matrix. Now the formula for the adjoint. The formula adjoint is that we're going to reverse the places of the A, and we're going to change the sign to B and C. All right, so I've not been seeing you post your answers, so I don't know if you're getting it or not. You're not giving me any feedback to let me know if you understand. So I'm going to assume that you do, and we're going to move forward. Good morning, Dinsmore. Morning, everyone. All right. So let's look at find the adjoint. And remember, you're going to need to find the determinant and the adjoint in order to the inverse of the matrix. So what we so far for matrices, we've looked at addition of matrices, subtraction, scalar multiplication, and 2 by 2 multiplication. And now we're finding the determinant and the adjoint, which will lead us to find the inverse of the matrix, which you could look at as division of matrix. Because remember, to multiply by the inverse is the same as dividing, right? And from there, we will go to solving simultaneous equations using matrices, of which you need to know the inverse to do that. All right, so step by step. So let's say we have, again, matrix A, which is A, B, C, D. The adjoint would be equal to, so look now, we're going to switch places A and D. So we have D and A there. And we're going to change the sign of B and C. So B becomes negative, C becomes negative. Or if they were already negative, they would now become positive. For example, if we matrix A, which is -3, 5, -1, to find the adjoint, which we can DJ, point would be, so we're going to switch places for the A and D. So the 5 would come here. That was D, it's now A. The -3 would come there. That was A, it's now D. We don't change the signs. For the A and D, you don't interfere with the sign, just places. For the B and C now, They don't switch places, but we change the sign. So this was -4, that becomes a +4. This was 1, it becomes -1. So that's the adjoint. Switch places with the A and D, it becomes DA. Whatever the B and C originally are, change the signs. If they are positive, change them to negative. If they are negative, change them to positive, but don't move them. All right. So let's do some examples of those now. So matrix B. So let's say we have 0, 3, 1, -11. So the adjoint ADJ would be switch place now. So it will become what? It will be -11, 0, and -3, -1. So we switch places with the A and the D, and we change the sign, whatever the B and C were. They are both positive here, so we change the sign. Let's look at matrix C. Uh-oh. So matrix C. So let's make everything negative. Everything. 7. So the adjoint matrix C B So exchange the A and the D. So it's now -6, -4. And so we don't change sign, we don't interfere with the actual number, we just switch places. But with the B and the C, we need to change the sign. So it was a -7, it now becomes a +7. It was a -5, it becomes +5. All right, so just like we're going to do 4 more. So that was C. All right, so D. Everything positive. 3, 9, 20, 32. The adjoint of this matrix would be, so we'll switch D and A. So this becomes 32, becomes 3. And C, we're going to change the sign, not switching them, just changing the sign. So that becomes -9, and this becomes -25. And for E, so we switch around the 4 and the negative. Change the sign to -6. Pretty simple. We're going to do 2 more examples just for good measure, even though I know that by now you have got the hang of it. Just do 2 more for the road. So let's find the adjoint for matrices F and G. So F could throw in some fractions, -3, 4, -2. So we switch around -2 and the quarter. That's -2 and a quarter here. Change the sign for the -3/5 and the +4. It's going to become a +3/5 and a -4. Example, just for good measure, don't pat because it's so easy weasy, cheesy peasy. So let's say -7, -7. I want to be mischievous this morning. So the thing is -7. What? We have to go to our extra one. This one doesn't count. So we're going to have -7, -7. Switch the A and the D and change lines for the B and the C. This one doesn't count. We have to do another one because it's a crazy one. All right. So one more for the road. I'm just trying to think of, I like to cover all my bases. Give you as many different kinds. I like to do that, but I think of different kinds of stuff that can come. All right, decimal 0.2, 3, -1.8, 9. Same principle though. This 9 is not representing nines properly. Same principle. It doesn't matter whether they count decimal, whole number, negative whole number, blah, 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 blah. So we know 9 is going to go there. We know 0.2 is going to go there. We know we need to change that positive and -3 and change that 1.8 to a positive 1.8. And that's the end because it's just too easy. Oh, that's it. There's nothing more to it. You've gotten the hang of it, and the next time we do a session, yeah, it's pretty simple, pretty simple, very easy. Nothing more to it than that. So you need to know these two things in order to find the index of the matrix, which is what we're going to do the next matrix session. So you'll have to put the determinant times the adjoint. So you must know how to find the determinant, how to find the adjoint. All you need to do is practice. Dinsmore, you're asking if I was on yesterday. No, I wasn't on yesterday. I was trying to sort out some of the technicalities, some issues we've been having on the live stream, and I think I've pretty much out. So in terms of the video quality, in terms of the glitching, the blurry screen, all of those, I think I've managed to resolve them. So I spent the time yesterday afternoon sorting those out. So hopefully when we go live again this afternoon, you will see me much clearer and hear me much clearer. And we can have a much better experience. All right, so having our live sessions this afternoon, as usual, the schedule remains the same. So that's it for matrices, finding the determinant and the adjoint.